Hi guys, it's Mr. T here. I'm going to try to make a video here today at my virtual beach here, and got my little beach Baja on here and everything. And we're going to make a little video trying to give you some help with the practice problems on the SAVVAS book on 1-3, Section 3, Topic 1, Section 3. I got one through question mark because I really don't know if it's going to time us out and we have to do 2 videos or not, but we're going to try to get all those done. And as always, if I'm doing something you don't need me to, you just fast forward it to the section. You can hit rewind. I might look at a problem 2 or 3 different ways, just so that trying to anticipate certain questions or give you some helps and some tips on calculator use and when to choose which calculator and what features of the calculator to use and all those sorts of things. So it ends up being a little bit long, but that's why you have the fast forward button and the rewind button, the change the speed button. Take care of all those things. So now I'm going to shut this off because, you can't pay attention to math with this good-looking face looking at you. It's a joke, okay? All right, but no, really, I'm going to turn the screen off here and the camera and just look at the problems themselves and get that. There we go. All right, so let's go over here to SAVVAS and get that up. So our first question here is, what do the closed and open circles on the graph of a step function indicate? Well, the closed and open circles are used to indicate which part of the domain includes the ends of the steps. A closed circle indicates the x value is included in that part of the domain, and an open circle indicates that the point is excluded from the domain. Let's check that out. And it says, excellent. Now this is unusual. I've never seen this before. It says it's the right answer and then explains what it's the right answer. I don't remember seeing that before. Well, isn't that nice? All right, let's slide on down here. Let's go to number 2. Well, while we're at it though, before we go any further, what we like to see here is, I've used an example in class, and I said the words Lincoln log about the open and closed dots, right? And so I was trying to get an indication about how different functions piece together, kind of like Lincoln logs, and you want some open ends and closed ends, but that really wasn't a good idea. I thought Legos, but no, not really. It's really more like this guy here. You've seen these little train and road sets up like this, and how those roads get put together. It's really more like this guy here. And you see where the opened end here and then the dot, you want those to kind of go together. If you have 2, closed end dots, it's really not going to connect well. You can put 2 open end dots, but then you're going to have somehow a way to connect them. And that's okay too. But that's 3 pieces, remember, where these 2 are connected with 2. If you want to do this, you're going to have to come up with a 3rd piece, which would, in our case, would be just a point, not 2 like it is here. But I think this really gives a good visual of what we want to do when we're piecing together functions. Not that we have to, but it is awful nice when we go from one to the next. And it doesn't have to go in this order, but they do need to have one closed and one open. And that's going with the equal sign and not having an equal sign, or the squared bracket, or the parentheses when we're using interval notation. But I think this kind of helps to visualize this idea and when we're trying to connect the different pieces of our piecewise functions. All right, so that was all bonus. How about that for you? All right, so let's go to the next question. Okay, and so find the domain and range whose graph is on the right. So figured out that yours is probably very similar to this, maybe exactly like this, but it's at least similar to this. Okay, so for the domain is what it's asking for first. So I'm going to hit this little button here, and I think it does good, but I'm going to go even bigger. And what I'm looking for here is, I'm going to take a draw. Let's get this thing out of the way. A little box. let's do a yellow box. Basically, and keep going until I hit something. See, I hit something there. So from the left to the right, that's the very first thing that happens. And then I'm going to go all the way over here to the right again. And see, this is where the next thing happens. So the domain's between these two boxes, correct? Well, that is seemingly true. And then I would come over here and say, well, that's right here, -7, because that's -7 here, right? Ooh, that's a little big. Let's undo that. I was making some big titles. Let's get this back to what we normally would do. Sometimes we'll just do that. It's still a little big, but we'll go with this. So this right here is -7, right? And then this here is 9. All the way up there. That X is still 9, isn't it? That X value is still 9. So we would think that this is correct. But I tried that and it said no. Now, why was that? Well, what happened here is this. See this little space right here? See if I can get this to do exactly without having to get it right. See that little space? There's a gap, right? So we're going from -7 over to 2, picking up at 3 and going to 9. And I come over here and I go like, oh, I see it now. I see it now. I see it now. So this is not the answer. It has these two pieces to it. And they're both closed dots. So they both got the squared brackets to them. So this is the domain going left to right. So there's nothing to the left here. That's the yellow. There's this gap here. And then there's this guy over here. So that's our domain from left to right. All right. So there's that. I'm going to go click it and see how this runs. Get that out of the way. Check that. And it should say excellent or good job. There we go. And that always nice. All right. Now it's the range. So I'm going to come back over here. So we're going to look from the lowest to the highest. The lowest to the highest. So again, I'm going to draw me a little box here to kind of help make this really, really clear why this is the lowest. So this is the lowest spot, okay? And what is the Y value at the lowest spot? The Y value right there is -8. So this guy right here is Y value -8. And we're going to go all the way up. We're going to go all the way up to here. No, to here. No, all the way up to here. This is as high as this thing goes. So, and there's no gaps in here either, right? It just keeps on going. You know, there's something all the way through here. So it goes from -8 to +8 up here. And this, since it's range, we're dealing with Y values, right? So that's the -8 to +8. And we'll look at that answer here in just a second. Once I turn off this little dude here, close that up. We'll see -8 to +8. They were closed dots on each end. And excellent. So there's number 2. Okay. Head on to number 3. All right. So this guy here. Let's see if I can get fancy here. I'm going to try to get fancy. I have my TI-84 virtual calculator here, but I also have hanging out is my Desmos. And let's see if I can convince this guy right here to split the screen with Desmos. There you go. You see that little thing come out? All right. Get that where we can see it. There we are. So let's come over here to Desmos. I'm going to have to clear out some things. And I'm going to do, man, it's hard for me not to write y equals, but I don't really have to here. So I'm going to do 1 divided by 2. You see how it automatically jumped into a fraction there for me? That's nice. X. And then come hit enter. And then I got X plus 4. Okay. So they kind of cross over, but we need to go back and add in, there's some limitations to these, right? So we got this brace, and I'm going to put x less than 0. Oops, I didn't hit the right button. Try again. There we go. Oh, my goodness. There we are. And then come down here. And this is going to be x is greater than or equal to. So I'm going to get my keyboard up here because I need my equal to. And then 0. And close it off. Okay. So going from left to right, we're doing just fine. And remember, we got on the green one, we have an open dot here and a closed dot up there. So from left to right, it's going to go on forever. So our domain is going to be just fine and well done. Okay. Now it's asking for the range. Well, at first I said, well, you put in 2 lines together, that's going to be negative infinity to positive infinity as well. But you see we have a gap here. We're gap here. So again, let's look at this idea. I'm going to draw my pictures in here. Okay. Now, it comes from down here, but this is really what? It's got an arrow on it. So this is going to be negative infinity. Well, that's an 8, for goodness sakes. Let's get my, I got this little tool here. Wow, that was crazy. Here we go. Negative infinity. And then up here, it's going to be positive infinity. But we got this space in between, right? And since we're writing on it, let's go ahead and get these in here. So this guy has an open dot, and this one has a closed dot. So from negative infinity up to what? What's the y value there? 0, okay? Because that's at the origin. And what's the y value here? 4, okay? So that, because that is the point 0, 4, right? So we're going to go from negative infinity up to 0, and that's going to be opened. That looks like this guy right here is pretty good, right? We got that straight. It's going to pick up at 4 and go to positive infinity. Oh, looky there. We found our answer right here. And so that has the square bracket off because it has a gap. Let me close this guy off here. Actually click it and hit enter. And voila, here we are. All right. Hopefully that's making some sense to you there. So let's slide over here to 4. Oh, now this one's definitely fun. Okay. So what we're going to do here is we're going to, so just put in 7 and greater than 3. Come down here. It says less than or equal to 3. Oops. Get that out. And then put in 5x minus 3. Okay. Now, this is interesting. Let me put this over here so we can see the whole thing better. Okay. Now, coming from left to right, it's coming from negative infinity up to 3, and then picking up from 3 and going on and on and on, right? Interesting. All right, this is different than I saw a while ago. Okay. Find two for the piecewise defined function. So that's what we just saw, right? Okay. Find two x values that have the same y value, and the sum of the x values is 10. Well, all I can tell you is they don't touch at all. But if they did touch, they would touch at what? At x equals 2? At x equals 2. So I'm not sure what all they're trying to get at, but I know the only time they share x values is when you let this guy keep on rolling, right? They would end up crossing at x equals 2, and that would be, and 2 plus 8 makes 10. So that's a little odd. That's a little odd. So, hopefully this video is going to help you, because I'm sure that's going to cause you a little bit of consternation there. It says great. I'm a little curious, and it says textbook, so it's not going to actually give you an example. So there we are on that end. Okay. So I graphed it, looked where they crossed if they were going to continue on, and that's at 2. And then it said it wanted the two numbers that added up to 10. So I just literally went down this list and said, okay, 2 plus 8 is 10. Easy enough there. Okay. It's a little odd. It's a little bit odd there. Okay, let's go to our next one. All right, let's go all the way here. All right. So the monthly water bill is a function of the number of gallons used. The cost is $10.50 for the first 10,000 gallons or less. Okay, so as long as you use 10,000 gallons or less, it's just $10.50 straight up. Now, after that, over the 10,000 gallons, the cost is going to be $10.50 plus $1 for each 1,000 gallons. Okay? Okay, with any fraction of the interval of 10,000 charged as a fraction of $1. Oh my. Okay, on what interval is the cost of the constant, and on what interval is the costing increasing? So coming up with the formula may be a little weird there, but coming up with some intervals shouldn't be too bad, because where's the cost constant? Well, it's constant from 0 to 10,000, right? Don't have to put that in there, but I'm going to put that in there so you can see it easier. So from 0 to 10,000, it's constant. And it says 10,000 or less. So I can put a square bracket on the end. And this is where it's a little bit of a weird thing. I would say you get a parentheses here because, well, that really doesn't count. You don't really do that. But they're going to put it in their formula. It said, because there is a possibility of you using no water, and we would charge you no money for that. There's another problem that we would put a parentheses here because it's a different real world situation. So for their formula, they're going to put a squared bracket there. And if that could cause you some troubles if you didn't do that, thinking you had the right numbers, but you had the wrong, you had parentheses there. So let's hit enter. Well, I'll be dog. I just did this. Watch this. Watch them do this. Oh, okay. See, this is one of those deals where sometimes it lets you put a comma in there and sometimes not. So I was right to begin with on this, I think. There we go. They did not like that comma because they thought those were three different things. All right. So there you go. Just one of the things about working with the software and learning when to do things and when it doesn't like to do things. All right, so the cost is increasing on its what intervals? Okay, well, it's going to pick up at when? $10,000, 10,000 gallons. So is that right? Okay. And it's going to keep on increasing. Does it say at a maximum? No, there is no maximum. So that's going to be positive infinity. It showed up. Okay. And we'll put parentheses on both sides because the 10,000 was already covered before. So put open parentheses there and hit enter. And very good. All right. So that's part 2. We got one more part here. Oh, is that it? Well, very good. So we learned a couple of things. Don't want that comma in there because it confuses it. And in this scenario, they included the 0 because there is a chance when they're setting up their formulas at the water company that 0 does happen. If you've been gone for a month on a big long trip, then that might be 0. And they'll probably send you a bill for 0 cents. Weird. All right, let's check out this next one here. And this is number 6. I guess I should start by putting in an actual number up here. So when people are scanning through, they'll be able to see that this is number 6. Okay. All right. Now, what are we doing here? There's a few ways you can do this. Check the result using your graphing calculator. So we could just type this into our Desmos or even our TI-84. It's a little more challenging there, but we can do it there too and just see which one it is. But I want to do this a couple different ways. First thing I want to do is get this -2 constant. So you see this is at y equals -2 down here. All of these are at y equals -2. But you notice the parameters here are both open dots. See, this is closed and open. So that makes this one not an option. This is open and open. So that makes this a maybe. This one is closed, closed. So this is a no. This is open and closed. This is a no. By just doing this one thing, we already know that this is no longer a maybe. This is a yes. Now, I've done this a couple of times, and sometimes there's more than one to choose from, okay, that's correct at that point. But that's the strategy I would use, is I'd pick one of these and check to see if they have the open dots and closed dots correct and eliminate some of my answers. Makes it pretty easy. So I was able to do this without ever punching a single button, okay? Let me come in here and let's pretend like for just a moment that this was, well, not this one. Let's do this one instead. I got another tip for you. Okay, another tip for you. Notice how this is a positive slope. So that's x plus 2. That's going to be a line, an x plus 2 line, right? Well, if I did x plus 2, it'd be right here, and it'd go up like that. Okay, it's going by 2s. And looky there. Isn't that x plus 2? And then 1/3 is a really steep line. And then there's 1/3. Okay? And there's 1/3. Where this is -1/3. So these are both going downhill, right? They're both going downhill in their slope, and these are both going uphill in their slope. Again, didn't have to use my calculator to make that decision. So I'm actually not going to use a calculator this round because you could, if you needed to. I've already showed you how to use Desmos to make this happen. Let me just click this here, and because I know this is the right answer, I'm going to hit enter, and good job. It would be really embarrassing if I was wrong and overlooked something, wouldn't it? It wouldn't be the first time, because I am human. Okay. Oh, we're getting more interesting now. Write a piecewise function. Okay. So we're going to have to write the equation and the inequality, the equation and the inequality. So I'm just going to slide this over here and make this bigger. Pull this over and make it even, not that much bigger, because I still want to have that space over here so I can write. All right, let's get this into writing mode. So I'm going to take this left equation, and I'm going to see, okay, if I continue this out, 0 would be my y-intercept, correct? And what is my slope? Isn't that -1? Okay, so my slope here is -1. My y-intercept is 0. So my equation for this one is going to be y equals -1x, which is just negative x. Oops. Negative x. And so that's my equation. Now, what is the parameters here? Well, this is going to go from small numbers up to 3 or -3, right? So this is x's that are smaller than -3. Now, is that open dot or closed? It's open, so I do not put my equal to sign here. So here is one of my answers. And so it looks like this one's going to go right here. Y equals -x, x less than -3. So that's one goes over here. And I'm going to change to blue. So let's look at this line here. They give, and on both of these, they gave you 2 points, so you could calculate slope. You can calculate slope, but I'm thinking it's pretty clear here that, well, let's double check. I think it's 1. But let's use the points just in case, because see how this was real simple, right across the diagonals? The way this is doing, because it's on a scale of 2, it's going 1, 1, 1, 1. Yeah, that's definitely a 1, but I could just come back in here just so I can be sure. M equals 4 minus -4. So there's my y values. 4 minus -4. Be careful of that. And then 5 minus, and then that minus what? -3. And so that ends up being plus, doesn't it? So that's 8. 5 plus 3 is 8. So M definitely ends up being 1. And my y-intercept here is going to be -1. Okay, it's my B. For my y-intercept, my slope's up here, so that's going to be y equals 1x minus 1, and it's going to start at -3 and go to infinity. So that's x is bigger than -3. Close dot, so I get the equal to. So this is my second piece of the puzzle, okay? And so I translate that over, and this is going to be y equals x minus 1, and then x is greater than or equal to -3. And since we got the f of x, it turns out I probably don't need to put the y equals here into the boxes because we already have y over there. Okay, so I'm ready to start typing. Pull that all out. Oh my goodness, I hope I can remember what it said. I can just do like this. Oops, too much. So -x and x minus 1. Got it. So this is x minus 1. And that was -3 because these are both -3. And then this was just -x. All I'm doing is typing what I said before. Good job. All right. So That was number 7. Yep. Number 7. Woo! Okay. I'm going to leave it sitting there for a minute. So if somebody's fast forward, they can actually see that big number, or rewinding. All right, close that off. Should have done that at the beginning, but we're figuring this stuff out as we go a little bit. All right, let's get this out of the way. And I think that'll do. We can probably see everything. All right, again, I'm going to go ahead and say this is number 8. Number 8. So the entire time I'm talking, if somebody's looking for number 8, they can find it. All right, so let's see what we got here. We're trying to match up this piecewise function rule here and what we see down here in the graphs. Okay, and it seems that they're all going to be up to -3 and then pick up at -3 and get bigger. So we're going to go x is smaller than -3 and x is bigger than -3. Okay, so that's x equals -3, x equals -3, x equals -3, x equals -3. So they all got that part correct. Okay, but it says the 1, okay, where y equals 1, you're right, y equals 1, that's the top line, right? The top line is y equals 1. We're going to use the numbers smaller than -3. Okay, these are the numbers smaller. So this one's maybe. Okay, maybe. These numbers on the positive one are bigger. So this is a no. From the y equals 1 line, that's bigger. So we're going to say no to it as well. And this one says, hey, our 1 is smaller. So that's a maybe too. Okay, all right. And then come back up here and we see that it says equal to. That's a closed dot. So we're going to say no. I mean open dot, and we want a closed dot. So here we go. This is no longer maybe. This is for sure. Got it. Got this one correct. Again, if you're welcome to put this into your calculator, but your calculator, a decimalist calculator, is going to give you A or D in this case. It's not going to tell you the closed and open. You're going to have to do that for yourself. Okay? Even with the use of a calculator. Excellent. All right. So here we go. We're keeping on cruising on. Let's go to number 9. Uh-oh. Nope, I messed up. There's a part 2 to this. Oh, I missed this earlier too, I guess. Okay. The range. Well, going up and down here, we simply the y values are either all -1 or all +1, aren't they? When you look at those blue lines, okay, you look at those blue lines, get that bigger. The y value for every single one of these is 1. The y value for every single one of those is -1. There's no other numbers used. So that is why they have a set notation set up here so that we can just type in -1, comma 1. Okay. And then we're in good shape. All right, let's see how that goes. Okay. It's probably the 3rd time I've looked at that question. I never got to that part 2. Oh, well. Just skimmed back on it. All right, now this one's interesting. Get this where we can see it. This is number 9, yeah. I'll get motion sickness on me here. Moving things around. All right. So we've got number 9. All right. So we've got concrete company delivers 100 charges $150 for delivering less than 5 cubic yards of concrete. Okay. So for 5 cubic yards and more, so this is different than that one earlier. Okay. So it's less than 5 cubic yards. And then if it's 5 cubic yards, then it pushes you over, not the other way around. So this changes where that closed dot and open dot would be. Okay. And the charge is $30 per cubic yard. And they're going to do that fractionally. So if it's 1.5, they're going to do this 1.5 times 30 is what that means. It's some fraction of this. So they'll do, 0.5, 1.5, 1.5, 1.3, 10.8, whatever that is, times 30. So that's what that fractional of a yard is. Okay. It says use a function notation to write the charge as a function of the number x in cubic yards delivered, where we're going to go from 0 to 10, graph this function. Okay, so notice it doesn't have an equal to because they do not need to calculate them never showing up. That would mean they need to calculate every person in the whole neighborhood that they never ever came to deliver concrete for. So whereas a water company needs to include 0 because they have water hooked up to every single house, right? Concrete company is not going to come to a house unless they're going to deliver it to begin with. So they do not have an equal to sign for their 0. Subtle differences, but in the reality of the real world situation, that's how that would work. All right, so let's get back over here. We're going to say, so anything less than 5 cubic yards, we're going to charge for $150. Is there any formula that goes with that? No. And so what I'm seeing here is for 150 from 0 to 5, that seems to make sense. Okay. What about this here? Square, well, that's area. So they're trying to distract us with area. And then we're saying, okay, so $30 for the extras plus the original. That's a possibility. But this would say if I plugged in a 1 here, what would that would be, well, I know if I got 1 cubic yard, it'd be 150, right? But if I plug a 1 in, it's going to be 30 plus 150. So that's not true. That's not true. Okay. And from 0 to 5 is not $30. No. So we're going to back up here. So it's for the first 0 to 5, we're going to get 150, period, cubic yards. And then once we hit the 5 cubic yards up to 10, we're going to do $30 times, whatever cubic yard that is. So I think we got this guy straightened out right there. Okay. So let's see how that goes. Check answer. Uh-oh. Did I not? Oh, I got to click it officially. And here we go. Fantastic. Now it says we want to do part 2 to this question and look at the graphs. Now, we don't need to go actually graph these. We just kind of look at what's going on. Which one of these shows that you're charged $150 for the first cubic yards and then it goes up from there? Well, this just says from 0 to forever, it's going to keep on rolling, right? This one says the first 150 depends on how much you got, but after that, they're just going to charge you a solid rate. That don't make any sense at all. This one says we're going to charge you just a little bit, but after you hit a certain amount, we're going to start charging you a lot faster. That's not it. And then we got, okay, it's 150 to this point, and then we're going to start charging you more depending on how much you got. That sounds like it is the correct one. And you notice something else I want to point out. This is the only one with an open dot as well. I don't think the other ones have an open dot right there. Let's see if this one does. I don't think it does. See, it's closed, so that makes it wrong already. So we could have done this one just because it's the only one with the correct open dot at the beginning of the domain. All right, so here we go. Click this guy, hit enter, and voila, here we go. Moving on. Number 10. Number 10. Now, this is a 4-part question. This is a 4-part question. And let me put number 10 on here, but it's going to go away pretty quickly. So we got 4 parts. But I want us to notice here something. And so I'm going to leave this on long enough and make some notes. They want to know, does this piecewise function have a range of negative infinity to 4? Does this piecewise function have a range of negative infinity to 4? And they're going to give us 4 different scenarios and ask the same question over and over again. Does this have a range of negative infinity to 4? This is where I think your decimals calculator is really going to be handy, okay? All right, so let me see if I can make this guy, again, split screen on me. There we go. Did it? No, it did, but I didn't let go at the right time. There we are. So let's come back over here. I think we can see everything. All right. Bring this guy up. Let's just clear these guys out and start from scratch. All right, let me close up my other pad here for just a second. Okay. So again, this time I'm going to put the y equals in because I just like to have the y equals. So I'm going to do x minus 3. And then left brace and say x is less than negative 2, and then close the brace. And then let's try this again. Y equals 5 minus x. And then for our domain, it's going to be x is bigger than 1. X is bigger than 1. Okay. Let me close this off. So again, we're talking about range, okay? Now domain, there's a big, huge gap in the middle here, but for range, let's see here, see what's going on. Between the two of these, if I go from negative infinity and come up to here, and what's this point? 1 and undefined. Let's go right there. Well, that's 3.9, right? Because see, it's an open dot, right? These are open dots, so I got to go here. 3.9 or basically 4. And see, that's a parentheses. So there'll be a y value all the way up to 4, isn't there? From negative infinity to 4 for the y values. Now, would this be true for the domain? No, it would not be true for the domain. But they're asking range. And so first time I went through here, I did not pay close enough attention, and because I assumed, and you know what happens when you assume, it was domain. So this is going to be a yes. Okay. Okay, nice work. All right, and it's going to keep on popping up. And it does say final check every time, so it's giving you one shot at this. So let's be careful that we click the right buttons. All right, and so I'm just going to change this out to -1. There are other ways we could go about doing this, but I think this is probably the quickest and easiest way to get this done. And it says 2 here and 3 minus x. Okay, so I've changed out what they have said. And let's look up here. So what is going on up here? Well, this is 1. Does it go high up? Does it ever touch 4? No, it never makes it up to 4. So this is going to be a no for the range. Well done. It likes that answer. Okay. So let's keep on rolling. And I could do this a little faster if I wasn't talking at the same time. Kind of like in class when you're trying to get work done and talking, not about math. But we're moving on. Sometimes it makes it more interesting. All right, as long as we're getting the work done, right? Okay. Okay, all right. Does it make it all the way up to 4? It looks like it's hitting 4 to me. All right, last time I went through here, this question was a no. But this time it looks like a yes to me for range. Well, we're going to find out. It says nice work. Okay. Cursor goes from negative infinity all the way up to 4. It doesn't include 4 because it doesn't have the equal to. All right, that's fine. And then lastly, D. So it's x plus 2. And got negative 2 here. And then x plus 4 and greater than 1. All right, here we go. So is this coming from negative infinity? Sure. And does it make it to 4? Why, certainly it does make it. Well, no, there's no 4 at all. There's a big, huge gap in here. So from 5 to 0 is missing. So that's definitely a no. It's definitely a no. It's got no in all kinds of ways. So that's a no. And boom, good job. We did good. All right. So that's all right. We can make that happen. So let's go on to 11. We're getting there. Oh, and this one's so straightforward, easy. Okay. It just simply says, given this deal here, A and B are real numbers, what's the vertex? Well, we said that whatever's sitting here, okay, it looks like it's negative A, but it's going to be positive A, right? And then the outside is just like it looks. We don't go changing the sign. That's what people get carried away with. They go say, oh, that's the opposite of A. So we're going to put A and then opposite of B and C. And then they might choose this answer down here, C in my case. But it's absolutely positive A and positive B. And so for just a moment here, let me put the big sign up here and say this is whoopsie, what did I do? Number 11. This one's super straightforward and quick and easy because we're just taking the A value, and I'm mostly taking a little bit extra time so that if somebody's cruising through, oops, hit the wrong button. The A and then the B, and we're going to leave that sign just like, and we're going to include this sign for the B, opposite sign for the A. Everything's all good. All right, one more. Let's see. Hello. Okay. All right. One more. Cha-ching. All right, this has got 3 parts, and this is actually a little bit of a challenge question, okay? So let's get this thing together here. Pull out my handy dandy little marker piece here. It's going to ask us for the domain and the range, and then it's going to want us to write all these equations. All right. So let's get this a little bigger. So once the domain, then the range, and then the equation with all the pieces to it. Let's see if I can kind of put this together for us, okay? Okay, and we said that this is number 12. Okay, so a while ago when we were doing domain, I put these little boxes up here, kind of help us out. So there's nothing to the left of that box, right? And on the far right, we have this guy over here. Move that over slightly so you can see what's going on. So the X value right here, that's what, -5, -6, -7, -8, -9. So our X value here is -9, and this is 1, 2, 3, 4. Okay, this is 4, comma 4. Whoops, 3, not 4. But in this point right here was what? This one right here is -9, comma 1. And for the domain purposes, we're looking for these two numbers right here. So, and it said interval notation, I'm pretty certain. Okay, so I'm going to jot this down on a piece of paper so when I get to it later, we can type it in and I won't forget what I said. -9, comma 4. And these are squared off brackets. Okay, so while these are points, the actual domain is going to be -9 to 4. And those are going to be included because those are closed dots. Those are closed dots. All right. So let me clean up some things here as we talk about the range. The range, we're looking for bottom and top, right? And then, okay. That worked. And here. See, that's an open dot there. Let's do this in blue. Okay, range. We're starting down here, and what is this? -5, -6, -7, -8, -9. So this is the point 0, -9. And go all the way up. And okay, keep on going up. And this is the point -2, comma 1, 2, 6, 7, 8. So -2, 8. So that's what this point is. And so for the range, okay, we're talking an open dot down here, right? And an open dot up here. So we're going to go with -9 and 8 because we're Y values. So -9, comma 8. And this time they both get parentheses, so they're open dots. Okay. So there's our range. Again, I'm going to need to write that down because when I close this down, I need to type it in and make sure I didn't make any boo-boos. Okay. Okay. That is not what I meant. Here we go. So let's get rid of these boxes. You notice we didn't use the same 2 points for the domain as we did the range. Sometimes they are the same points, sometimes not. If you don't get caught up on that, because you're looking from left to right and top and bottom, sometimes they are used again for both, because that point is both the left and the bottom, or both the right and the top. But that's not always the case. So don't look for any kind of pattern there. And one thing I wanted to take note of here is something you could lose. This is a closed dot, comes up to an open dot. You go straight down, closed dot. So we have that open dot, closed dot linkage that we talked about at the beginning, right? See this open dot, closed dot linkage, and keep on linking it together, right? So let's see if I can. Well, that's close. Here we go. And then closed, and then back to open, and then closed. So even though they're three different pieces from left to right, they're linked together. All right, the last step is to do the equations and the restrictions. The equations and the restrictions. So let's see. Get back over here to my pen. And I think it might be best if I clear this out and put the answers in real quick. Okay, so -9, 4, closed, enter. Fantastic. Okay, now it says the range. You notice it has a set notation, but that's not going to be needed in this case. So parentheses, -9, 8, closed, enter. Fantastic. Okay. And now here we go. So we have 3 different pieces for this piecewise. So you see there's 3 lines on this A choice. There's only 2 lines on the C choice, so that's bad, and the D choice. So it's either A or B. And then you notice how this is going from to, and this one's going like from negative infinity to here and there, and then positive infinity. All right. Are there any arrows? No. So this setup here, this B setup, is not going to work out for us, okay? Now, if there's arrows on the end of these, that might work out for us, but there is not. So we're going to go from to, and see it says equal to and such. So this is the one that's correct setup for us. So let's see if I can get this, manipulate this to where it's easier for us to see the setup. Nope. It is not going to cooperate. Okay, there we go. That's what I was looking for. All right. Now let's start marking on it. Okay. So here we are. Let's just start off on this far left one here. And so let's figure out the slope and the y-intercept. The slope and the y-intercept. And that's we'll just start with red, and then green, then blue. Okay. So let's do this red one here. The slope is what? Up 1 over 1, up 1 over 1, up 1 over 1. So our slope is 1. Now our y-intercept, we don't quite know, but it's really close, right? If we continue this on, that's going to be what? 10, 6, 7, 8, 9, 10. So our b here is going to be 10. So that's going to be y equals 1x plus 10. And what's our domain? -9 to -2. Closed, open. So I'm going to go ahead and transfer that information over and put this as -9. See the close there? And then -2, which is opened. And then this would be x plus 10. So that's our first little deal. So now let's go to this next piece, which could easily get stepped over here. Okay, and this is constant line here, and it goes from -2 to 0. So -2 to 0. From -2 to 0. You see that open and then close, that linkage? Okay, so that's real nice. And the equation is just -6. Y equals -6. Y -6. Because that's -6 right there, right? Cool. All right, and then our last one here, I'm going to do this all in blue so we can keep track. it starts at 0 and goes to 4, doesn't it? X equals 4 and x equals 0 and x equals 4. So that's 0 to 4. Okay, for that. And now we got to come up with the slope and the y-intercept. So I'm looking at here, and it's going up 3 over 1, up 3 over 1, up 3 over 1. I think we figured out the slope is equal to 3. And the y-intercept is, what is the y-intercept? Okay, well, I've kind of marked over some things. -5, -6, -7, -8, -9. Okay, -9, all right. So B is -9. So our equation is going to be y equals 3x minus 9. So 3x minus 9. Give me a second to write this down on a piece of paper so I can, when it clears out, I can transfer it. -6, 2, and 0. 3x minus 9, 0, and 4. Okay. So thank you for your patience with that. All right. Okay. And let's type in some stuff here. We said that was x plus 10, -9, -2, -6, y equals -6 for the constant, -2 here, 0, 0, 4, and then this was 3x minus 9. All right. All right. Let's see how it goes. It says good job. So, all right, we're done through 12. That's through 12. Okay, guys. So, as always, I hope that's helpful. We made it through the whole thing. It didn't shut us off. I don't no idea how long it took. But again, you can fast forward and rewind as you need to. And hope I'm filming this. The day I'm filming this is we're actually out of school for a day for weather and sickness, which is whatever. I guess the sickness was worse. But I hope that was helpful as always. Have a good break. See you when we get back.